I loved playing Sekiro, but I had a problem. I had no skills. Rather than trying to get good at Sekiro, I decided to get good at hacking games, and made an easy mode for Sekiro.
Let's go!
To hack games, we first need the ultimate tool for hacking games, Cheat Engine. If you haven't used it before, Cheat Engine allows you to scan and edit memory of another program, like Sekiro in this case. Before we start hacking, I'll start a new save and progress the game a little bit.
Hours later.
Oh, this has gone pretty well. Maybe I don't need to hack the game. Never mind. To make our hack, we'll need to find the address of the player's health value. We can't see the numeric value in the game, but Fextralife Wiki has kindly provided us with the max value of player health, which is 320. So, at full health, we can assume that the player's health value is 320. Let's do our first memory scan of 32-bit integers equal to 320. So, the initial scan found 23,000 values, which is a lot. Now we need to start filtering them down. We'll go ask our nice friends for a cigarette. And now our health is no longer 320, so we can scan for values that are now less than 320. We try to give our friend a hug and then we scan again. Rinse and repeat. Using decreased value scan type is actually better. Now we can go get ourselves healed up and we can scan for the maximum health value again. Alright, only 6 results left. That's much better. If we hug our friend again, we'll notice that all 6 values are the same. So all of them are copies of the health value. One of them is the actual health value or the source of truth. Others are things like UI state and other stuff that we are not really interested in. We can find the source of truth by adding all of the values to the address table and trying to edit them one by one. If the value goes right back to 320, we know that it's not the source of truth. But if the value changes and you see the new value in the game, then you know that it is the source of truth. Cheat Engine has a feature that can freeze the value of a memory address to its current value. If we do this for the health value and go for a high five with our friend, we'll see that we do not lose health. Now we have essentially made God mode. But there's a couple problems with this approach. For one, the memory address will change whenever the game is restarted, so we would have to scan for the health value all over again. Second, we can probably still die if we take more damage than our max health value. And third, most importantly, God mode is boring. We want to make the game easier, not trivial. So to make things more interesting, we're going to need to write some assembly code. We right-click on the health memory address and select Find what writes to this address. This opens a debugger for the process, and Cheat Engine will detect the addresses of assembly instructions that write to the address, allowing us to essentially find the code that changes players' health. Now let's ask our friend to go for a beer with us. After that, we have 2 entries in the debugger. One is being constantly called and the other has only been called once. From this we can assume that the second one is the code that changes the health value. We save the address of the instruction and view it in the memory viewer. This move instruction copies a value from registry EAX to memory referred by the address in RBX registry and increments it by 130 hexadecimal. We can decipher from this that EAX contains the calculated new health value and RBX contains the health value address being written to. Now we open up AutoAssembler and use templates, Cheat Engine table framework and code injection. This generates some assembly code for us that will replace the original instruction with our own code. Our own code will be a single jump instruction that will simply skip over the original instruction. We save it into our address table and activate it. Now, when we take damage, the game will not change our health value at all. The unfortunate thing about this code is that it's not only managing the health of the player, but also every other character in the game. So any code change here will apply to all characters. We need a way to differentiate between the player and other characters. For that, we need to find more health addresses. We do this by right-clicking on the instruction and selecting Find out what addresses this instruction accesses. This opens the debugger again, and when we pat our friends on the back, we can capture their health addresses as well. We save them to the address table and look at them with the memory viewer. From the move instruction we can make another assumption. The 130 hex offset indicates that we are accessing some kind of data structure here. This is probably a C++ class that represents a character, and that offset 130 is the character's health. So if we take the health addresses and reduce them by 130 hexadecimal, we get to the beginning of the data structure. We save the address of the player and the two enemies to the address table. We see that all structures have the same 4 bytes at the beginning, which supports our C++ class theory. Now what we need to find is data in these structures that is different for the player compared to other characters. We don't know what this data actually is, and we don't really care. The only thing we care about is that it's unique to the player. On the third row we can see some data that is 0 for the player but non-zero for the enemies. Good enough for us. The only way to know if this data is unique to the player would be to compare it with every other character in the game. But that's a lot of work, so we'll take our chances with this. We'll calculate the offset from the beginning of the data structure and write this value to a registry in our injected code. We use ECX because it's not used by the original code. Then we add a compare instruction, comparing the value with 0. We use J&E instruction to jump to the original code if the value is not 0. Now any code after this will only apply to the player. We'll test this by doing the same as before, skipping over the original code. And would you look at that? It works! The player is immune to damage, while enemies are not. Another thing we need to check is whether the new health is higher or lower than the current health, as this code runs on all health change events. We don't care when healing happens, so we compare the new health with current health and jump to the original code if the new health is higher. Alright, now we need to turn God mode into a damage reduction mode, which requires a bit more code. Here we take ECX, which is the amount of damage taken, convert it into a float and multiply it by a constant that we have defined here. Then we convert the result back into an integer and subtract it from the current health. In this example, we only apply half of the incoming damage. With this code, our secret handshake with our friend is a lot less painful. With this upgrade, I can barely survive against the first boss. Progress. Progressing through the game, I noticed that I am surprisingly tanky when my health is low, and realized that this damage reduction code is a bit more powerful than you would think at first. Because we are not actually looking at the damage here, we are looking at changes in health, and the value of the new health is capped to 0. It does not go below 0. So for example, if the incoming damage is 100 and we have 10 health left, our health is set to 0. When we look at the difference between new and old health, we get 10, and we multiply that by 0.5 to get 5. Meaning now we have actually caused a 95% damage reduction instead of just half. We could explore the game code a bit further to find a place where the proper damage is calculated, but at this point it's easier to just boost the damage we do rather than reduce the damage that we take. But why do just that? Instead of playing with health, we can modify posture damage instead, since it's arguably a more important stat in Sekiro than health. Finding the posture value is now easier since we have already the address of the player's health. We can just keep an eye on the memory viewer when taking posture damage and see what values change. We have a couple of values here that are the same. We add both to the address table and try modifying each one. This one seems to be the source of truth for posture. I do the same steps as before, finding out what writes to the address and injecting code into that instruction. And now we are immune to posture damage. Then we pretty much copy-paste the code from our health script, but we reverse our logic, applying the damage multiplier for enemies only and setting the multiplier to 2. We also use the offset of the posture value instead of health, of course. Let's test it out. Yep, it seems to work. To be sure, let's amp up the multiplier to 5 and go tickle a giant. Yep, that seems about right. And there we go. We have created a difficulty setting for Sekiro in the form of a posture damage multiplier. But I wanted to be a bit fancier.
Many hours later.
So I made a custom program with Rust that can do the same code injection, but without cheat engine. This consists of an executable that injects a DLL into the game process and also modifies the game code. The executable calls a function in the DLL that initializes some assembly code and returns the address to that code back to the executable. The executable then replaces the original game code to instead jump to the code in the DLL. In the DLL, the assembly code pushes registry values onto the stack and then calls a C-compatible Rust function, passing the new posture value and character pointer to it. This allows me to perform the posture value modification in Rust rather than having to write more assembly code. Finally, the assembly code restores registry values from the stack and jumps back to the game code to continue execution. Once we start the executable while the game is running, we enter a posture value multiplier and we have the same effect as we did with cheat engine. Okay, now we're done. Thanks for watching the video. If you liked it and want to see more game hacking videos, leave a like and comment below if you have any ideas on what I should be hacking next.